MAT1033 Final Exam Review Question 87. You're supposed to determine if this relation is a function and then find the domain and range. You're given a set of ordered pairs. Three, 5, negative 2, 1, 5, 1, and 2, 3. So you want to know, is this a function? Now remember what we look for. We look for repeating domain values. There is not an x-coordinate that repeats. So each x-coordinate corresponds to exactly one y-coordinate. So yes, it is a function. You could also graph these ordered pairs as points in a plane, and then if you perform the vertical line test, if it passes the vertical line test, then it is a function. We want to determine the domain. The domain is the set of x values, preferably in order from smallest to biggest. Well, I'll write them that way. Negative 2, then 2, 3, and 5. Okay, and then you're looking for the range. It's also something you were asked to find, which are the y-coordinates, again preferably in order from smallest to biggest. Now you see that 1 is here, appears twice, but we only need to write it once to represent that value, and then the other two y-coordinates are 3 and 5. So yes, it is a function. There's the domain, there's the range. MAT1033 Final Exam Review Question 88 says to state the domain of each function, write the set using interval notation. If you recall, domain is the set of x values, the input value, that will give you a real y out. If you look at problem A, we are dealing with an oblique line, a linear function, and the values of x that I could put in to get a real y out would be all real numbers. Therefore, the domain for this function would be all real numbers in interval notation. That's parenthesis, negative infinity, comma infinity, parenthesis. Part B, when dealing with a rational function, this is an equation that has a fraction in it. We consider all the numbers that would make the denominator 0 and include those values from the real number set. So we set the denominator equal to 0, solve this for x. Those are the values that I cannot use in the real number system to use as a replacement for x to find a real y, because that number 3 would make the bottom of the fraction 0. So I list the domain as all real numbers except 3. And to show that in interval notation, it would be parenthesis, negative infinity, comma 3, parenthesis, union, parenthesis 3, comma infinity. The parentheses must be used to show non-inclusion, and the union joins the two sets. That's the domain for a rational function. And the last type of function we dealt with in this course was a square root function, and that's what C is. Y is equal to the square root of x minus 5. And with a square root function, in order to get a real number out, the radicand must be greater than or equal to 0. So to find the domain of this function, I take the radicand and I set it greater than or equal to 0. Once I solve this for x, I can find the domain. So x minus 5 is greater than or equal to 0. Solve for x. X is greater than or equal to 5. And the domain would be all real numbers that are greater than or equal to 5. So the domain starts at 5, includes the values, so bracket 5, comma, and anything bigger than that, to infinity, parenthesis. That's the domain.